Okay, so we're going to do the practice free response question for your semester 2 common assessment. It's probably going to help you out if you look over the question while we're doing this one together. There's also an answer sheet you can look at the same time. So our problem is in 2004, the Rosetta spacecraft was launched from Earth with the mission of intercepting a comet. Assume that after launch, the Rosetta spacecraft's distance from Earth can be modeled using the function f of t equals negative 27t squared plus 384t, where t is measured in years since 2004, and f of t is measured in millions of kilometers. So what we're going to do is we're going to make the graph. Let's go ahead and plug that in. Negative 27, I'm using x instead of t squared, plus 384x. We hit enter, and oh no, we just have a straight line. What are we going to do? We got to zoom out. I'm going to do a zoom fit. That usually works out pretty good, but it's still not so good. I probably want to be looking up in this area right here. So I'm going to go zoom. I'm going to zoom out over that area. And now I can see what I'm looking at. I'm going to zoom in again at the top of my parabola here. Now I got a pretty good view. I'm going to click and hold and drag that label out of the way so we can see what we're working with. Okay. Question A now says, how far is the Rosetta from Earth at t equals 2.46 years? To do that, all we're going to do is we're going to do a graph trace menu, trace, graph trace, and you want to know 2.46. To do that, just type in 2.46 and hit enter. And there it goes right here. It tells us that when t is 2.46, we are at 781.247. But of course, we need our units. What are our units? Well, we know f of t is millions of kilometers. So it is 781.247 million kilometers. That's a long way away from Earth. That's our answer to part A. Part B, now according to this model, when will the Rosetta spacecraft touch down on Earth again? If we're touching down to Earth, we are not anywhere away from Earth. We are 0 kilometers away from Earth. You need to find the 0 of this graph. To do that, the calculator will do the whole thing for you. You're going to go menu, analyze graph, and then look at the top. We have 0. These little lines are going to pop up. You want to put them around your 0, which we can see is right over here. And there we go. Our 0 is at 14.222. Remember, in Algebra 2, we always go to 3 decimal places unless the question says otherwise. And what we need units, of course. What are our units? They are years since 2004. So 14.22 years after 2004, the Rosetta is going to touch back down to Earth. Okay. At what time will the Rosetta be farthest from Earth? Farthest from Earth. That's going to be its maximum distance away from Earth. The maximum distance away from Earth. The calculator, again, can find this maximum for us. Menu, analyze graph, maximum. Those dotted lines are going to come up again. We want to put them around our maximum, which we know is right here. And there we go. And let's get that out of there. And there the maximum pops up right here. The data point is 7.111, comma, 1,365.333. But of course, that's just our coordinate point. That's not actually answering our question. At what time? That's going to be our x value. And the farthest distance, that's going to be our y value. So we can say 7.111 years after 2004, the Rosetta is at its farthest distance away, which is 1,365.333 million kilometers away. Okay? So those are our first three questions. Oh, calculator turned off. What we're going to do now is question D. At what times is f of t greater than 756? So what we're going to do to figure that out is we are going to place a line on the graph at 756. Then we are going to see when our parabola is above that line. So hold on one second. I'm cleaning up the graph here, getting those data points out of the way so that we can see this a little easier. Have it up here in 1 second. All right, so here's my graph again, all cleaned up. And like I said, we want to put a second line right here, just a line at 756. If we want to know when f of t is greater than that, here's a sketch, and then here's my 756. We're talking greater than 756. That's going to be all of this right here, this arch in your parabola. So when is that happening? I'm going to need to know this point and that point. To do that on my graph, I'm going to go to Menu, Analyze Graph, Intersection. We're going to put, again, those lines around our points. There's the first one, and we're talking about the win. The win right here, that's at t is 2.361. And on the other side, Menu, Analyze Graph, Intersection. Again, you're going to put these lines, the dotted lines, around that intersection point. And I didn't do a very good job decluttering this. I apologize, but I'll let you know what it is. It's 11.862 is my x value or my time. So this means that the t, at what times is it greater than this? In between 2.361 and 11.862. This inequality is the answer to when f of t is greater than 756. So what does that mean? It means, well, what does this mean? The Rosetta is greater than 756 million kilometers away between 2.361 and 11.862 years after 2004. So that is our answer to D. That's our answer to D. All right, let's take a look at question E now. It says, determine the average rate of change over the interval 8.1 to 9.7. So in order to do that, I need to know what our value is at x is 8.1 and when x is 9.7. To do that, I'm going to go back to my graph trace. So we go to trace, graph trace. Let's start with 8.1. I just type it in, and it appears right here at the bottom. At 8.1, we are 1,338.93 million kilometers away. Now I want to know 9.7. I type in 9.7, hit enter, and we get the y value of 1,184.37 million kilometers away. So the average rate of change is just our change in the y over the change in the x, which, what does change mean? The difference, subtract y2 minus y1 over x2 minus x1, which is going to be 1,184.37 minus, calculator in the way, 1,338.93 over 9.7 minus 8.1. I can do that denominator in my head. That's 1.6. The numerator, I cannot. So I'm going to go to the calculator. And that's 1,184.37 minus 1,338.93, which is negative 154.56. I divide that by 1.6 and I get my rate of change of negative 96.6 million kilometers per 1 year. What does this mean? Are we getting closer or farther away? We are getting closer. How do I know we're getting closer? Because our distance away from Earth is getting negative, or that means it's getting smaller. So you would also write that the Rosetta is getting closer. Okay, question F. We've got this comet, and its function is this right here. When are we going to intercept? Well, they're going to intercept when they're at the same point. To do that, we are going to, bell ringing. To do that, we are going to plot the other graph, negative 33.1 x squared plus 440x plus 78.1. And we get our second graph. It's kind of hard to see. I'm going to do another zoom fit. And they are going to be the same when they are intersecting. So menu, analyze graph, intersection. That we can see they're intersecting right there. When will that be? Our x value here is 10.41. So they will intersect 10.41 years after 2004. Good luck on the common assessment, guys. You guys are going to do a wonderful job.